Well, Multimedia Science is back, and today we're going to look at another computer application, this time the energy changes game. I used to teach the types of energy and definitions, and I was really surprised to find that as soon as I gave the students some examples, like a Rube Goldberg machine, and asked them to point out the way that energy changes from one form to another, the students really did poorly. So I ended up spending a lot more time on how the energy changes from one form to another to make sure that the students really clearly knew exactly where the energy was stored. I also found that some of the questions were pretty difficult, even for me. So this is the energy changes game. We'll start it. You can see here I decided on 10 types of energy. You could certainly add pressure, for instance. I just thought 10 was a nice round number. The way the game is going to work, there's going to be an in energy and an out energy. And the box here will have some kind of an illustration, some kind of an occurrence, and that will be what you'll have to base your in and out energy on. So here we have a mousetrap, and we can guess.
Congratulations.
I just clicked by accident and got the right answer. So the input energy is the spring, which holds the energy. The output energy, let's see, heat. Oops, not this one.
Wrong.
And
very good.
You can see that the spring energy gets changed into mechanical energy, the movement of the device itself. Of course, the final repository of the energy would be heat, but we're not asking that question. We're asking exactly where does energy A go to the next energy B. Okay, now we have a match that's being struck. Notice it says ignore the friction needed to ignite the match. So we're asking, well, what energy was actually in the match to begin with? Let's see.
You lose. Well done.
So it was the chemical energy and the chemicals on the end of the match.
Wrong.
Let's see.
Yes.
Well done.
Now notice in this case that the answer is heat. That's because the most likely use for the match would be to heat something up. There would actually also be light energy that would be given off, but the students should be prompted to give the most likely energy when there's only one possibility. Here's a tree, and the sun is beating down on the tree.
You must have goofed up somewhere. Wrong.
Hopefully you can see that the tree is getting light energy from the sun. Obviously it's nuclear energy in the sun, but again we're talking about what is the energy that's actually entering the leaves of the tree, and then hopefully you can see that it's chemical energy that is used or ended up from the photosynthesis of the tree, takes the light energy and turns it into chemical energy. Okay, we've jumped ahead a couple of questions. Notice that the in energy is at the top and the out energy is not kinetic. So hopefully you can see that the in energy at the top is the gravitational potential energy, and then at the bottom it's the movement of the energy through the mechanical parts of the device. In this case, it's in Newton's cradle. As the problems go along, they get more difficult. In this case, there's a more than one energy change being illustrated. We've got an electric pump moving liquid upward, and we're going to ignore the kinetic energy change. So let's see.
Correct.
Of course, it's the electrical input to the pump, and then the pump
This. You must have goofed up somewhere. Oh, I'm a failure.
Very good.
The electricity turns the pump rotor, which means that it's giving the pump mechanical energy, and then it pumps the water up, which is, let's see,
Yes.
gravitational potential energy. Here's another problem where you can see that we have a battery attached to a coil around a nail. Of course, this is an electromagnet. You can see if we turn it on, it becomes magnetic. We turn it off, it's not. A little difficult here. Where is the original energy? Well, hopefully you can see that it's chemical. The chemical, of course, gets turned into electrical.
Correct.
And the electrical finally into magnetic energy.
Yes.
We could take it one step further and have put a fourth one on, is that it takes that magnetic energy and turns it into gravitational, actually kinetic energy, and then ultimately gravitational energy. At the end of the game, after the 20 problems, students will get a final score out of a possible total of 245 points. If you were working in a computer lab, you could walk around and take students' scores as a way of assessment. You could also use this in front of the classroom with a projector or a whiteboard. So if you're interested into looking and finding more information about the Energy Changes game, please go to Teachers Pay Teachers. This is the URL, and search for the Energy Changes game software.